Female reproductive system with the ovaries inside the body cavity, the uterine tube or fallopian tube, which leads to the uterus, the cervical opening, the vaginal canal, and the external structures of the female reproductive system. A frontal view is probably a little easier to relate to. A pair of ovaries with the uterine tube or ovarian tube leading to the uterus, cervix, and the vaginal canal. Function of the ovaries is to, number one, produce eggs, and number two, produce estrogen and progesterone, the hormones that are in part responsible for the 28-day cycle, also for development during puberty, and a variety of other things in maintaining the reproductive structures. Uterus is there to house the developing fetus and create an environment suitable to embryonic development. The vaginal canal receives sperm from the penis and also is the pathway where the uterus expands into during pregnancy. External structures of the female reproductive system. We have labia majora and labia minora surrounding these structures. At the lower end of the opening of the vaginal canal, there are a pair of glands called the vestibular glands. And the function of these glands is to secrete a lubricant during arousal so that it facilitates penile penetration. The vestibule is the area in and around the vaginal opening and the urethral opening. And the clitoris is above the urethral opening at the roof of that vestibular area. When we talk about the physiology in female reproductive system of erection and orgasm, this physiology is very, very much like the male reproductive processes as well. Erection is carried out by the parasympathetic nervous system, orgasm by the sympathetic nervous system. So the physiology here is remarkably similar. Again, erection begins with some sort of visual cues or mental cues, and you have dilation of the arteries and blood vessels that service the clitoris and the labia majora and labia minora, allowing them to engorge with blood. The nitric oxide, again, is responsible for that vasodilation, that increased blood flow. The vagina expands and elongates, the vestibular glands secrete, and the labia engorge with blood and swell. Shifting over to orgasm is a sympathetic response, not parasympathetic. Vagina swells, creating increased friction for the penis, and that is to encourage ejaculation, because if there isn't any ejaculation, there won't be any babies. Peristaltic contractions help propel the sperm toward the cervical opening. And the very same release of endorphins in orgasm in females as in ejaculation in males. Those two responses are remarkably similar as far as that goes. So when you're looking at the female and male reproductive systems, even though they're extraordinarily different, there are some functional and physiological similarities. Over here we have testes, and they produce sperm and they produce hormones. And over here we have ovaries, and they produce eggs, and they produce hormones. We have the vas deferens, which is the pathway that is taken by the sperm during ejaculation, and then we have the uterine tube, that is the pathway that the egg takes upon fertilization to the uterus. We have the bulbourethral glands, in the male that help lubricate the glands of the penis. We have the vestibular glands in the female that also lubricate the labia. We have the glands of the penis for sensation and stimulation, and we have the clitoris with similar type of sensation and stimulation. So that there are a variety of structures, although very different in location and looking, have very similar functions, so that there's a fair amount of similarity between male and female reproductive systems, even though they appear to be quite a bit different. Now, the hormone activity in females is a little bit more sophisticated and involves more hormones than that in males. Once a male reaches puberty, his testosterone levels remain relatively constant throughout his adulthood. There's a kind of a 24-hour cycle. There's greater amounts of testosterone early in the morning, and it tends to diminish over time, but that can be altered by various things. But basically, there's a continual release of testosterone. In females, there are actually 4 hormones that they're interplaying with one another once a female reaches puberty, and they continue to interact in this 28-day cycle until a woman reaches menopause, and then they diminish significantly. The 2 hormones that come from the pituitary gland are LH and FSH. And the 2 hormones that come from the ovaries are estrogen and progesterone. Now, prior to puberty or during puberty, these hormones have different functions than they do once the 28-day cycle is established. Okay, so in the development of a female, these sex hormones, which are listed on your outline there, the anterior pituitary releases FSH for sex cell maturation, and LH stimulates the release of estrogen and progesterone. The ovaries release estrogen, which then are responsible for maturation of secondary sex characteristics in the female, and progesterone, which stimulates breast growth and initiates the female 28-day cycle. So they're involved in puberty, the development of the reproductive organs, the development of the breasts. But once the 28-day cycle begins, then they take on a more specific function and a more repetitive 28-day cyclical function. And that's what's listed here. And basically what this is explaining to you or trying to illustrate to you is that it is LH and FSH that initiate this whole process, because it's the spike in those 2 about midway through the cycle that causes eventually the release of the egg and the development of the uterine wall, both of which have to occur in order for pregnancy to occur. So LH and FSH, the job of those 2 hormones are to cause the ovaries to mature and release an egg. So under the menstrual cycle, FSH stimulates maturation of the follicle, and LH stimulates egg release. They also encourage the release of estrogen and progesterone. So without FSH and LH, estrogen and progesterone levels would not spike as well. So that's another effect that they have. But the effect of estrogen and progesterone is not to release the egg, but to grow the uterine wall down here, to add layers and layers to the uterine wall. First with estrogen, which initiates the process because it spikes earlier, and then progesterone, which continues the process because it is slightly delayed, to get a very glandular uterine wall. And without that glandular uterine wall, implantation of a fertilized egg will not take place. So you both have to have ovulation, followed by fertilization, followed by implantation for this whole process to function successfully to develop a pregnancy. There's one problem with this 28-day cycle, however, and that is estrogen and progesterone crash as a result of the crash of FSH and LH. So the spike in FSH and LH initiates their release, and the sudden drop then results in a prolonged drop a little bit later, drop of both estrogen and progesterone. And therein lies the problem, because without estrogen and progesterone, this uterine wall cannot be supported. And as estrogen and progesterone levels crash, the uterine wall gets shed, causing your period, only to begin that whole process all over again. However, if there's a fertilized egg implanted in this uterine wall, and the uterine wall gets shed, so will the egg, the fertilized egg, be shed. So something has to arrest that process so that pregnancy will occur. Now, before we get into that, what that does, what causes that, I want to show you a little bit of logistics here, because this is something you need to understand to be able to follow this. At about day 14, because of FSH and LH, ovulation occurs, and it takes about 5 days for this egg to travel down the uterine tube to reach the uterus. It's a slow journey, facilitated by those cilia of the epithelial tissue that's lining this uterine tube. An egg has only about a 48-hour window to be fertilized. Beyond that time, fertilization probability drops way off, which means that fertilization is going to have to occur pretty close to the uterus, pretty close to the ovary, because if this is a 5-day journey, then day 2 and day 1 and day 2 are somewhere in here. That also means that if a sperm is ejaculated into the vagina, it first has to swim through the cervical opening, up through the uterus, go up through the uterine tube, and all the way to here in order to fertilize that egg, because that time frame is limited by the egg and also limited by the sperm. Sperm can only fertilize an egg after ejaculation plus about 48 hours as well, so that 48-hour window has to coincide. And it takes probably 12 to 24 hours for the sperm to reach the egg. Once it's released, many of the sperm remain in the vaginal canal. It's a good thing you got 500 million of them, because the mortality and the confusion is incredible in there. Many of the sperm try to fertilize the uterine wall, the vaginal cavity. Some of them never find the cervical opening, so they never get into the uterus. Some of them try to implant in the uterine wall or fertilize uterine wall, and when they get up here, they've got to either turn right or left. And men, they don't ask for directions.
That's right.
But there is some information available to the more astute sperm, if you will, because the egg releases some chemicals that waft down this uterine tube, and if the sperm picks up on those, he knows which way to go. So more than half of the sperm go the right direction. The other ones generally find a blind alley, because ovulation is usually the release of just one egg. Often it can be left ovary, right ovary, left ovary, right ovary. Sometimes one ovary releases 2 eggs. Sometimes each ovary releases an egg, which can lead to multiple births. But fertilization has to occur somewhere in here. Then, over the next several days, it has to come down to the uterus and implant in the uterine wall. So if this is day 14 here, this is day 16, 17, 18, 19, about day 20 is when implantation occurs. And day 28 is when the uterine wall is going to be shed. And so something between day 16 and day 28 has to occur to prevent that uterine wall from being shed, or else this pregnancy will be lost. And what that is as these cells divide upon fertilization, this dividing group of cells starts to release its own particular hormone called human chorionic gonadotropin. It does not come from the mother. It comes from these dividing cells. And human chorionic gonadotropin is what they use typically in pregnancy tests to determine whether someone's pregnant or not, because the byproducts show up in your urine, and the only source of these byproducts would be a dividing group of cells to illustrate that you're pregnant. But if you were to take that type of pregnancy test right away, it would show up negative because it takes a while for that hormone to peak. And if you were to take it in the 2nd or 3rd trimester, there isn't very much left, and you probably would get a negative there. Now, there are some newer pregnancy tests that you can take within, what, 24 or 48 hours? But I don't think they're cued in on HCG. I'm not quite sure what they are cued in on. But what HCG does is this. When HCG is released right after fertilization, it surges significantly, and that surge goes back, that chemical goes back to the ovaries and stimulates the ovaries to increase their release of estrogen and progesterone. And so, if you go back to look at the 28-day cycle, with that in mind, what that does then is HCG begins to be produced somewhere in here, and instead of these hormones crashing like this, they continue to rise throughout the pregnancy. And since they don't crash, the uterine wall is maintained, and the pregnancy then can take. And it's HCG that is also responsible for morning sickness. Has a greater effect on some women than others. And it's also responsible for interrupting the 28-day cycle typically, because a rise in estrogen and progesterone arrests that 28-day cycle, prevents ovulation from occurring, and therefore eliminates that type of 28-day cyclical response during the course of the pregnancy. Not always the case, but often the case of that. So HCG is the hormone that allows the pregnancy to continue. Something else that I wanted to say. Let me see what I left out.